Myself, Dr. DR.S.B.SIRSATH, Department of Chemistry, Yashwant Mahavidyalaya, Nanded. As all you know very well, the so many topic is completed from paper 1 by our teacher. Now I think this is one of the last but one topic from your syllabus. The name of the topic is called as Solutions and Colligative Property. As all you know very well, solution and colligative property is important topic because so many questions in examination they ask by considering the solutions and colligative properties. Why? Because inside of these solutions we have so many concentration terms. On the basis of that concentration terms, we require its calculation like normality, molarity, mole fraction, percent by weight, percent by volume, etc. In this topic, dear students, we learn what is a solution, what is its types of solution, and what is the methods or ways for expressing the concentration of solution. As all you know very well, after completing the methods or ways for expressing the concentration of solution, the next and very important part, that one is called as the colligative property. In your syllabus, you have a 4 colligative property like elevation in boiling point, depression in freezing point, osmotic pressure, and finally the next one, very important colligative property, that one is called as the lowering of vapor pressure. And once if you know the colligative property, then what is the meaning of abnormal colligative property, that concept also present in this syllabus. This syllabus is a very important to your syllabus, that's why you must be very serious with this. I will explain you each and every point with numerical, because numericals of this topic is very important. See, dear students, before going to start this topic, I will define you what is the meaning of solution. So see, what is the meaning of solutions? Actually, all you know very well, solution is nothing but, the definition of solution is very simple and like this: solution is a homogeneous mixture of 2 or more component which is non-reacting. Listen very carefully. You concentrate on my word, the word which I used in the definition. The solution is nothing but, or the solution is a homogeneous mixture of 2 or more component which is non-reacting. Non-reacting means what? Suppose for example, dear students, suppose for example we have a beaker, and in this beaker we are taken the water molecule. This is a water molecule, and inside of this water molecule we are added the sugar, no doubt. After addition of sugar in water, the sugar dissolve in the water now, because sugar are soluble in the water. Sugar dissolve in water is not a chemical change, it is a physical change. You got it? Because property of sugar as it is present in the solution also. It means that when we add sugar in the water, sugar doesn't react with the water, because sugar is one component, water is another component, and these two components must be non-reacting with each other. If these 2 components are reacting with each other, then at that time that one is a chemical change and some new product is formed. But in solution we don't consider chemical change because it's a physical phenomenon. So what is the definition of solution? Suppose for example we mixing 2 or more component, but that mixture must be homogeneous now. Whenever the mixture is homogeneous, then at that time we say it is a true solution, or then at that time we can say it's a real solution. That one is called as very important things, because when the sugar dissolve in the water, then particle size of that sugar in water is not visible, that is invisible for naked eye as well as ultra microscope. Is it okay? So that's why by considering this phenomenon, then how to define the solution? The solution will define like this way, write down in your notebook also. The solution is a homogeneous mixture of 2 or more component which is non-reacting. Is it okay? Now dear students, while preparing solutions we have 2 very important things, because for your syllabus these 2 things are very important. The solution we prepared by using 2 things, that one is called as, one is a solute and other one is the solvent. So what is the meaning of solute and solvent? Listen very carefully. The solute is nothing but, solute is the component of solution which is present in smaller proportion either by weight or by volume. Suppose for example we are preparing the solution, if we try to make the sweet water or sweet water solution, then for water makes a sweet, suppose we are taken 1 glass of water, and 1 glass of water required only 1 spoon of sugar na, because after addition of 1 spoon of sugar, then 1 glass of water becomes the sweet. So sugar is a very minor component na, and water is a larger quantity. So what is mean of solute? Solute is the component of solution which is present in smaller proportion by weight or by volume. Whenever we prepare the solution, in that solution which is a smaller portion, or that one is called like the solute. So as per my idea, you got the meaning of definition of solute, no need to repeat this concept. So what is the solute? Solute is the component of solution which is present in smaller proportion either by weight or by volume. So this is called like the solute. Now dear students, what is mean of solvent? Now solvent is the component of solution which is present in larger proportion na. It means that whenever we prepare the solution and the larger part of that solution is nothing but the solvent. So solute and solvent, these two parts are very much important by considering your phenomenon. So as per my idea, you don't have any problem related with the solution, because you know very well, solution is nothing but it is a homogeneous mixture of 2 or more component which is not reacting. Generally solution is made up from, because actually what happened here, in classification of solution, in first classification of solution, we consider here binary solution. The classification depends upon number of component in the solution na. You go very systematically. Binary solution, then finally ternary solution and quaternary solution. My dear students, what is the meaning of binary solution? The solution which is made up from only 2 component. What is meaning of ternary solution? The solution which is made up from 3 component. What is the meaning of quaternary solution? The solution is made up from more than 3 component, that is 4 or more than 4, that one is called as the quaternary. But for your syllabus, the binary solution is very important. What is the meaning of binary solution? The solution which is made up from the 2 components, and out of the 2 components, one is the solute, other one is the solvent. What is a solute? Solute is the component of solution which is present in smaller proportion either by weight or by volume. And what is solvent? Solvent is the component of solution which is present in larger proportion by weight or by volume. So this is the very important and introductory part of this topic. You know, if I ask you the question, when sugar dissolve in water, then sugar is the solute na. Why sugar is the solute? Because sugar present in smaller proportion, therefore we people say sugar is the solute. And water is the solvent. Is it okay? Water is the solvent. Suppose for example, so NaCl dissolve in water, that is called as salt in water, sugar in water, etc., etc. Is it okay? Now dear students, I will give you classification of solution. Listen very carefully, because solute solvent phenomenon is very important. Now in classification of solution, actually 3 classification is there. First classification depends upon number of component present in the solution. Number of component present in the solution. Number of component present in the solution. Depending upon number of component, solution are classified as number 1 binary solution, number 2 ternary solution. What is the meaning of binary? What is the meaning of ternary? And number 3 quaternary solution. So as per my idea, you don't have any problem. What is the meaning of binary solution? What is the meaning of ternary solution? What is the meaning of quaternary solution? What is binary solution? The solution which is made up of only 2 components, that is for example A and B, then such solution is called as binary solution. What is the meaning of ternary solution? If solution is made up from the 3 components, that one is called as A plus B plus C, that one is called as ternary. And quaternary solution means solution is made up from 4 components. But actually in real practice, preparation of ternary and quaternary solution is very difficult. Why? Because the homogeneous mixture and non-reacting, these 2 things is very difficult to maintain the ternary solution and quaternary solution. Therefore, for our syllabus, binary solution is very important. Is it okay? You know very well, in binary solution we have a solute and solvent. So this is the first classification. Now I am given to you the second classification of the solution. Second classification depending upon the size of, listen very carefully, depending upon the size of solute particles. This is very important, depending upon the size of solute particles. Now dear students, whenever we discuss about the size of solute particle, these are the very interesting phenomenon. Whenever it have 3 types. The first type is called as the coarse mixture. First type is called as the coarse mixture. Listen very carefully, what is the meaning of coarse mixture? The second type is called as the colloidal solution, depending upon the size of particle. The first is called as the coarse mixture, is also called like the suspension, for your kind information. And last part is called like the true solution, This is very important to us. Now dear students, the first classification depends upon the number of components, might be binary solution, ternary solution, quaternary solution. What is binary solution? If solution is made up from the two components, ternary 3 and quaternary 4. Now the second classification depends on the size of solute particle. Listen very carefully. What is the meaning of size of solute particle? What is the meaning of coarse mixture? The coarse mixture is that in which the solute and solvent not become the homogeneous. It is a heterogeneous mixture. Is it okay? It is what? Heterogeneous mixture, the solute and solvent. And the solute particle is visible for naked eye as well as ultra microscope. It means the solute particle which is present in the coarse mixture, we can see by naked eye. If we see the solute particle by naked eye, then such mixture is called like the coarse mixture or suspension. It means size of solute particle is very bigger now. Size of solute particle is very bigger. It means that, for example, if we consider the mixture of salt and sugar, example of this one is, for example of this one is mixture of what? Mixture of salt and sugar. Dear student, the salt and sugar 100% visible to our naked eye. When we mix together, obviously, and then such mixture is called like the coarse mixture. As per my idea, you don't have any problem in the coarse mixture. What is the meaning of coarse mixture? The coarse mixture is nothing but it is a heterogeneous solution in which the both component, that is solute as well as solvent, is visible for naked eye as well as other. If we see by naked eye, it is no need to see by using ultra microscope na. It is very simple things na. Therefore, the example of this coarse mixture is mixture of salt and sugar. This is called like the coarse mixture. Now, what is the meaning of colloidal solution? In rough definition or in simple definition, we people say like this. The colloidal solution is nothing but it is a mixture of solute and solvent in which solute particles are invisible for naked eye but visible for ultra microscope. It means that the solute particle which is present in the colloidal solution we cannot see by naked eye but we can see by using the ultra microscope. Is it okay? So dear student, we can see by ultra microscope means what? The size of solute particle in colloidal solution is smaller than the coarse mixture na? And actually the size of solute particle is in the range of 10 raised to minus 7 centimeter to 10 raised to minus 4 centimeter. So this is the range of that solute particle which is present in the solution. For example, in colloidal solution, suppose is it okay? As per my idea, it is formed when the size of the particle dispersed in a solvent are in the range of. Is it okay? What is the definition of colloidal solution? It is formed when the size of the solute particle, listen very carefully, it is formed when the size of the particles dispersed in a solvent is in the range of 10 raised to minus 7 centimeter to 10 raised to minus 4 centimeter. So this is the beautiful definition of this colloidal solution. It means that what is colloidal solution? The size of solute particle dispersed in a solvent is in the range of, what is the range of that solute particle? 10 raised to minus 7 to 10 raised to minus 4 centimeter. Then such solution is called like the colloidal solution. Or the second definition, the solution in which solute particle is invisible for naked eye but visible for ultra microscope. It means the size of solute particle is something small, then such solution is called as the colloidal solution. Dear students, you know very well colloidal solution is a part which is already present in your 11th standard. That one is called as, I think, the state of matter, that in that topic, or surface chemistry actually. What happens really in the colloidal solution? You know, in colloidal solution, solute particle have either positive charge or negative charge. You know, while preparing colloidal solution, we have two things. One is dispersion phase, other one is a dispersion medium. In colloidal solution, we can't use word solute and solvent. We use word dispersion phase and dispersion medium. What is the meaning of dispersion phase in colloidal solution? Dispersion phase is nothing but our solute in true solution. And what is the meaning of dispersion medium? That one is solvent. So dispersion phase or dispersion medium in colloidal solution have a charge, or they are charged species, either positive charge or negative charge. It means dispersion phase carry either positive or negative charge, and due to charge that colloidal solution is formed. I will give you example of the colloidal solution. Suppose, for example, we consider ferrous hydroxide solution. Suppose the best example is ferric hydroxide solution. Ferric hydroxide solution. This is a example of colloidal solution which is called as the ferric hydroxide solution. After that, second example we are considering arsenic sulfide. The second example is called as the arsenic sulfide. The second example is the arsenic sulfide. So this is nothing but the colloidal solution. As per my idea, you don't have any problem. Now, dear students, what is the meaning of true solution? This is a real, this is our requirement. Now, I will give you simple definition of the true solution. Suppose, for example, if I ask you the question, suppose I have one glass of water, or suppose I have one beaker, that is 500 ml beaker. In that beaker, I am taken the water. Suppose, for example, I am taken the 250 ml of water, and in that 250 ml of water, I add just 4 gram or 3 gram of NaCl, sodium chloride. Now, dear students, tell me, after addition of that NaCl in that 250 gram of water or 250 ml of water, then after some time, the particle of sodium chloride is invisible for naked eye as well as ultra microscope, because that particle size become very small. The particle size become less than 10 raised to minus 8 centimeter, less than 10 raised to minus 8 centimeter. Is it okay? It means that the particle or the solute particle which is present in the true solution is definitely invisible for naked eye as well as ultra microscope. Now, this is interesting. This is very interesting. It means what is difference between these three? In coarse mixture, the particle is visible for naked eye as well as ultra microscope, because size of the particle is bigger than this. In colloidal solution, the solution is made up from the solute particle is in the range of 10 raised to minus 7 centimeter to 10 raised to minus 4 centimeter. It means the size of solute particle is very small. This solute particle is invisible for naked eye, because this we cannot see by naked eye, but we can see by ultra microscope, because size is something smaller than the coarse mixture. In colloidal solution, dispersional phase have either positive charge or negative charge, because colloidal particle is a charged species. Is it okay? Example is ferric hydroxide solution, arsenic sulfide solution, and so on. What is the meaning of true solution? The true solution means the solute particle have a size smaller than the 10 raised to minus 8 centimeter. That one is invisible for naked eye as well as ultra microscope. It means it is a real homogeneous mixture of 2 or more components which is non-reacting, and such solution is true solution. And in this topic, we consider the true solution. Is it okay? It means what is the meaning of true solution? A true solution is formed when soluble substance are dissolved in the solvent. Obviously soluble substance, because salt are soluble in water now. The size of the particle dissolved are very small, is in the order of 10 raised to minus 8, less than 10 raised to minus 8 centimeter. The size of solute particle which is present in the true solution is less than 10 raised to minus 8 centimeter. True solutions are homogeneous and cannot be separated into component by simple mechanical method. We can separate colloidal solution by either electrophoresis, etc., because we have so many methods to separation of colloidal solution. We have separate the coarse mixture. It is a very simple things, but it is very difficult to separate the true solution. It is not possible easily to separate solute and solvent, because size of solute particle is very small, and this is the second classification which is very important to you. So as per my idea, you don't have any problem. Therefore, now what is the real definition of true solution? Now it is a homogeneous mixture of, or it is a true solution is defined as homogeneous mixture of 2 or more substance. The composition which is not fixed and may be varied within a certain limit. Composition is not fixed within very certain limit means what? I will explain you. Actually, true solution means what? Suppose for example, we have 100 ml of water, and the limit of that salt dissolved in that water is only 10 gram. It means 10 gram NaCl dissolved in 100 gram of water. Up to 10 gram NaCl, that solution becomes the true. But if we add 11 gram of NaCl, then additional 1 gram of sodium chloride doesn't dissolve in the water, then that solution never becomes the true solution. Is it okay? Because this is the very important phenomenon related to you. You must know the things that one is called like the saturated solution, unsaturated solution, and supersaturated solution, because saturated, unsaturated, and supersaturated phenomenon present in your chemical equilibrium topic that have a very interesting phenomenon. In chemical equilibrium, you have one point that one is called like the solubility product. While calculating the solubility product, we require the sparingly soluble solute, but at that time you must know all types of solute, that is saturated, unsaturated, and what is supersaturated. What is the meaning of saturated solute? The saturated means what? The more solute can be dissolved in solvent. More solute can be dissolved in solvent means what? This is a definition of saturated solution, a very simple definition. The definition of saturated solution is like this: more solute can be dissolved in solvent. It means what? The capacity of that 100 ml water is for 10 gram of NaCl. It means 10 gram NaCl dissolved in 100 ml of water. If we add only 8 gram of NaCl, it means more 2 gram NaCl dissolved in that water na. Therefore, more solute can be dissolved because solute present in smaller quantity as compared to its capacity. Then that is saturated. What is unsaturated? No more solute can be dissolved in the solvent. Excess of solute cannot be dissolved in the solvent, and supersaturated means excess of solute present in the solvent. That is, if we increase the temperature, solubility increases. At lower temperature, excess of solute present in that particular solvent na. So that one is very important, because in true solution, correct definition, listen. A true solution is defined as homogeneous mixture of two or more substance. The composition which is not fixed and may be varied within a certain limit. After limit, we cannot add the solute inside of the solvent. So this is the second classification which I considered very systematically in the classification chemistry. As per my idea, you don't have any problem related to you. So this is first classification depends on number of component. The second classification depends on the size of solute particle. Now dear students, we are moving toward the third classification inside of this, because third classification also very important related to this phenomenon. Now third classification is called like the actually types of solution, or depending upon the third classification, depending upon physical state of solute, depending upon physical state of solute and solvent. So dear students, these are the very interesting part of this topic, the solutions. Now the third classification depends upon the physical state of solute and solvent. Now what is the meaning of physical states of solute and solvent? How we define this on the basis of physical state of solute and what? Solvent. Listen very carefully. Physical state of solute and solvent. Now depending upon the physical state of solute and solvent, I will give you one example, then later on we will discussing this point. Now dear student, salt plus water, salt present in solid state, water present in liquid state. So physical state of the solute is solid and physical state of the solvent is liquid. It means solid dissolve in liquid na. Is it okay? Solid dissolve in liquid. But my dear student, the major component is liquid na. Therefore this is liquid solution. Is it okay? Listen very carefully, because it means solute dissolve in solvent na. Solvent cannot dissolve in solute, that is solute dissolved in solvent. So what we people say that this is a mixture of solid in liquid na. This is a mixture of what? Solid in liquid, because solid is a salt and that one is act as a solute which is present in minor proportion, which is present in smaller proportion. Is it okay? And liquid is a solvent na, which is present in larger proportion. Yes or no? So listen very carefully, this is very important. Liquid is a larger proportion. So what we people say about this solution? We people say like this: the salt in water is nothing but solid is dissolved in liquid. So solid is a physical state of solvent and liquid is a physical state of liquid is a physical state of solvent and solid is a physical state of solute. So this is the, so depends upon the physical state. Now dear student, now suppose now we first consider here, this is a serial number, no doubt, and this is a first we taken the solvent and then we taken the solute. What is the physical state of solute? And if you know the solvent and solute, then we go toward the best example related to this phenomenon. Best example, okay? Now what happened in this case? Suppose we consider serial number 1. Now we consider serial 1, 2, 3, because solvent is solid, solvent is solid, solvent is solid. First we consider solid solvent. Now if solvent is solid, then this solution is also called like the solid solution now, because major component of this solution is a solid and minor component now we changes here. Now first we consider that is solid in solid, then solid in liquid in solid, and finally gas in solid. Okay, solid in solid, liquid in solid, gas in solid. Now what is the example of solid in solid? That one is called like the mixture of metal. You know very well, mixture of metals, and in short we people say mixture of metal is nothing but the alloys. All alloys is nothing but the solution of solid in solid. You know, dear students, this solution cannot satisfy the definition of our true solution, because it maybe happens the solute particle is visible for ultra microscope, therefore this is not a real true solution, this is not, therefore solid and solid we cannot consider in a practical way. But this is one type of solution, this is one type of solution which is called as solid in solid. So which one is example of solid in solid? Mixture of metals, that is alloys, you know alloys, for example brass, you know, for example steel. Brass steel is a not a pure metal, it is a mixture of metal, and that one is called as the alloys. For you just consider here, whenever we say something about the mixture of metal, that one is called as alloys. So alloys is nothing but the mixture of solid in solid. So this is the very systematic way which we are considered for the solution phenomenon. That one is called as solvent is the solid, solute is the solid, example is the mixture of metal, that one is called as the alloys. Now dear student, example I will give you the brass, bronze, copper in gold, etc. The example of this is, for example, we consider here brass, second example we consider here bronze, third example copper in gold, etc., etc. So this is the first example which is considering the first classification on the basis of physical state of solute and solvent. Now the second classification, that one is called as the solid in liquid, second classification. Solid in liquid is nothing but, the example of this is, you know very well, amalgams, you know, that one is amalgams of mercury with metal, amalgams of mercury with any metal, because metal present in solid state and mercury present in a very minor component, because it's, you know, it's a sodium in HZ, so many chemical reactions are there. I will explain you in organic chemistry. In organic chemistry, we have so many chemical reactions. Inside of this, we use sodium in so NaHZ in water. NaHZ. What is the meaning of amalgam? Amalgam present in smaller quantity. Amalgam is amalgam present in liquid state. And when this amalgam we use in any solid metal, then this becomes the solution of liquid in solid. Best example, amalgam of mercury with metal. The last example, solid in gas. Dear student, hydrogen gas, listen very carefully, this is also very good. Hydrogen gas on metal surface, you know, because in organic chemistry you have so many reducing agent, for example H2 in presence of nickel or platinum or palladium, this is a very beautiful reducing agent, you know, it have a very good reducing property, because this reducing agent first attacks on the symmetrical double bond, this never attacks on the unsymmetrical double bond, because this reducing agent have a very interesting property. So this is the first three types, solid in solid, liquid in solid, gas in solid. Now another see toward this, now the second physical state we consider after the solid, solvent is liquid and solvent is liquid. We people say this is liquid solution, these people say solid solution. Now this is the liquid solution. Once again the liquid in solid, then liquid in liquid, and then finally liquid in gas. Dear student, solid component, liquid in solid means what? Example, very simple example, NaCl in water, yes or no? NaCl in water, because NaCl is a solid which is present in smaller proportion, because solid is a solute. The second example, sugar dissolved in water. No need to explain example of liquid in solid, because this is a common solution. Okay, liquid in liquid, very interesting example, alcohol plus water, because alcohol dissolved in water. Dear student, you know very well about the property of this alcohol, very interesting. Ethyl alcohol is a very important solvent in organic chemistry, but majority people use this the use of ethyl alcohol. Listen what I am saying to you, because alcohol plus water is no doubt it's a physical phenomenon, it's a hydrogen bonding phenomenon. Hydrogen bonding is nothing but the physical force. So alcohol plus water is a mixture of liquid in liquid. Alcohol soluble in water, that's why the most of the people are use this alcohol as a beverages purpose. Actually alcohol is a very important solvent in organic chemistry, but we people cannot use 100% alcohol from the industry, because most of the alcohol is misused by so many people, doesn't matter, so that one is not important, alcohol plus water. And the second, liquid in gas, because gas is a solute which is present in smaller proportion. So the best example of liquid in gas, Oxygen in water, you know very well oxygen in water, because in sea oxygen present in the water, that's why the aquatic animal are survive. Oxygen is water. Example CO2 in carbonated drinks, you know very well CO2 in carbonated drinks means what? You know thumbs up, you know Coca-Cola, thumbs up, Coca-Cola. What's happening in the thumbs up and Coca-Cola? That carbon dioxide gas enclosed in the water molecule at high pressure, and that one is nothing but the solution, and that solution is called as the liquid in gas. Now dear student, now the last type, which is called as the 7, 8 and 9, which is the gas. For example, next gas, for example gas, this is called as the gaseous solution. This is called as the gaseous solution. Now first you see gas in solid, the second gas in liquid, and finally gas in gas. Dear student, solid is a smaller component, gas is a major component. This is called as the dust particle present in air. No need to say, because best example, gas in liquid, liquid smaller proportion, gas must be present in the higher proportion. The best example, chloroform in nitrogen, chloroform in liquid state, and nitrogen gas in gaseous state, and finally gas in gas. That one is called as the mixture of air, that is non-reacting gases which is present in the atmosphere. That one is called as the gas in gas. So dear students, as per my idea, you don't have any problem in this classification. So we systematically consider the classification on the basis of physical state of the solute and solvent. So these are the 9 classes, but the first class we cannot consider here. Solid in solid, solid in liquid, solid in gas, liquid in solid, liquid in liquid, liquid in gas, gas in solid, gas liquid, gas gas. So this is solid liquid solution, and this is the gaseous solution. These are the example. The remaining part of this topic is we are discussing in the next video. Thank you very much.